Hello everyone, welcome back to another Watch Me Do Math video. In today's video, I want to talk about what Math Olympiads are like, and why it's important for you to know about them and the spirit of them, even if you don't plan on participating in any of them. Because I don't know, I just feel knowledge of this is something that can have a lot of value, and I want to share it with you guys. So, to you guys, Math Olympiads are hard exams. The majority don't score above 33%, for instance, on this British Mathematical Olympiad Round 1, this paper. But even though they are both hard and, to many people, inaccessible because they might be locked behind qualifying exams and so on, it is really, really valuable to know what they're like. So, what are they like? As I mentioned, these tests are often locked behind some qualifying exam, so there's a tendency for some people to put them on a pedestal and say, it's a really hard version of what we're doing in school. And to some extent that is true, but also to some extent that is not the case at all, because it's just different from what you do in school. In school, a lot, not all, but a lot of maths is assessed in the sense that you have learned a technique or an operation in a textbook, and you just need to demonstrate in the exam that you can perform that operation or use that technique to solve a problem that's sort of been designed for you specifically to use that technique to solve it. But in Maths Olympiads, questions are usually a little longer and more detailed, not broken up into parts though, but not broken up into parts because you're expected to sort of see the question and come to your own conclusions about what mathematical tools or weapons in your armory, so to speak, you're going to use to construct a chain of logic exploring a situation until every logically correct step you made leads you to some conclusion. So for instance, if we look at question 2, a sequence of integers a1, a2, a3 satisfies the relation, this relation basically, which is tells you something about how one term is related to the next. And then it says, what are the possible values of a1, the first term in the sequence? And you might need to consider that, like, this is a question that I solved already, so like, don't take this as me just going off the fly. I know how to do this question, and it's like I've gone through preparation. The integers are said to be, the sequence is said to be of integers, so that's some extra information you can use. And the fact that that expression on the left of the first three terms looks like what happens when you square 2x plus 1 or 2x minus 1 might also lead you to some conclusion. And basically, you might come to the conclusion that that could be rewritten as 2 times the next number minus the first number squared is equal to 1. And yeah, this, like, coming to random conclusions like that do not necessarily bring you any closer to solving the problem unless you do something with them and take them even further. So what this question has done basically is construct a mathematical playground for you to mess around in until you find something interesting. And perhaps the interesting things that you find might be helpful to solving the problem or learning more about it in the direction that they want you to within the question. And the way it feels to take this kind of exam is you go into a room, they give you this question sheet, which is a small piece of paper that has these 6 really deep questions, but no supporting structure within the questions. And then they give you a stack of blank paper, and you can write up your answers to these questions, which often will be several pages of chains of logic. And they send them off, and a person who is mathematically skilled will mark them. And the way they mark them is not like a typical maths exam. There isn't really a mark scheme. It's more of a, because it's a 0 to 10 point scale, you can either get 0 points, in which case you haven't solved the question and will be minorly rewarded for any insights that you did have, so maybe up to 3 or even 4 marks if they're feeling generous. And if you did solve the question and you did come to a conclusion that they wanted you to show was true in the question, then you will get 10 marks, and some marks will be deducted for minor errors in your presentation, or logical sequencing, or omitting some edge cases that should have been included, and so on and so forth. But if you get the main idea of the question, you will get close to 10 marks. And correspondingly, it's impossible to get a middling mark out of 10 for any one question. So you can't really get a 5 out of 10 or a 6 out of 10. And I think it used to be the case that you couldn't get a 4 out of 10 either. So it's marked like a piece of art. Like the marker does not have any mark scheme to compare your written answer to, but the marker is someone who knows the craft of mathematics and can judge whether your logical sequencing holds true. They can judge the style of your logical sequencing. They can judge whether the layout and presentation, sort of the way in which you are rigorous or imprecise, contributes to making the answer mathematically good. Sort of in the same way that an English literature essay is marked. Because in English literature, you're analyzing some source material, right? And there are tons of ways you could go about it, but there is a valid logical structure to be upheld. And what matters is that you are making the arguments in a logical way, rather than just fapping around with the language tools that you have. So, likewise to there being no mark scheme for a literature essay in which many possible correct logical answers exist, the same is true for these maths questions. So yeah, it is really different from the kind of past paper grind that you might do in a regular maths course, at least in secondary school. So why is it important for you to expose yourself to these kinds of maths questions, and why is it important for you to be aware that these kinds of math competitions exist? Well, the first thing is that it broadens your horizons on what is possible with the simple mathematical tools you have already learned to use in school. And the thing is, as I mentioned before, when you learn to use mathematical tools in school, sometimes it might feel like you're being a chimpanzee trying to do a certain thing. Like, for instance, one of my friends remarked to me that the ways of solving differential equations that were dealt with in IB higher level maths, analysis and approaches, felt like a bag of tricks that you just had to learn individually and know when to apply. And as long as you kept practicing the tricks, you wouldn't have any problems in the exam. But these Math Olympiad questions are designed specifically so that while the actual mathematical knowledge you may need to do the questions is not crazy, like for instance, many mathematical Olympiads deliberately avoid any calculus-related topics, although it is completely fair if you want to use calculus to solve them. Like they avoid calculus-related topics so that they can take more basic mathematical topics and go as deep as they possibly can in their use of them. So for instance, that question 2 doesn't really like the techniques you use don't really have huge amounts of technical difficulty, like recognizing that it's in the form a squared minus 2ab minus b plus b squared, like recognizing that it's a square of a linear of a binomial thing, and then recognize that you can move the 1 to the side, and so on, things like that. They're not actually that hard, and students would have been exposed to them in mainstream mathematical education, but it's just that the application of them requires such creativity or such original thought, and the fact that they may be applied in super counterintuitive ways when the intuition of how to apply them is so built up by this really standardized question and answer format that is in traditional maths education. Like, seeing these kinds of questions broadens your horizons on what you can do with the tools that you already know, but perhaps don't know how to apply so complexly, if that's a word. And the next reason I think it's important for you to expose yourself to these mathematical Olympiads, or these kinds of problems, or the existence of this exam, is that it's sort of a window into what mathematical education could be if the focus was on generalized logical problem-solving ability, or sort of cultivating people's ability to think originally or independently. So this is sort of like, there's a certain level of technical knowledge that you acquire in school that is then applied creatively in this context. And I think it is a shame that our education system has it built up that way, rather than everyone learn to think creatively, and those who can learn to think creatively with technical information or with technical content. Because the more important of these two facets of someone's mathematical knowledge, that is, one being the creative side, the ability to think logically and originally, and the other being the technical side, the ability to use formalism, basically. The more important of those two facets of mathematics is, in my opinion, probably, almost certainly, going to be the sort of logical, creative problem solving. Like, if you had a 5-year-old, it would probably be more worthwhile for you to get them to like play board games like chess, checkers, mini shogi, and try and practice having them think through possibilities in the game or strategies or stuff like that, so that they can simply hone their ability to think logically, and introduce the formalism, like writing down these symbols on paper to symbolize the abstract concepts of numbers being added together and multiplied together and so on. Introduce that later when the mental bandwidth is there. So these like questions give a window into what mathematical education could be. And if you haven't been exposed to anything like this before, it may make you think differently about the maths that you do learn. It may make you think harder about what it is that you're actually learning, and force you to understand it better if you want to apply it in a more complex situation. And thirdly, which is less important, it's that this is more like what real mathematicians do, or real scientists do, physicists, computer scientists, whatever. Because sort of scientists and mathematicians, quote unquote, out there in the real world have to be original. Like, there's no like answer key they can look at to make sure their published research is correct. There's only experiment or logical consistency. And the ability to do things with original thought is most important if you want to be that kind of academic. Because otherwise, if no one is pushing on the horizons, of what we know, we won't know anything else, right? If people are focused only on learning how to do stuff that is sort of handed to them on a silver platter within the sort of IBHL math textbook, for instance, then there is like less understanding of what the people at the frontiers of the subject are actually doing. And not in the sense of you need to know what people at the frontier of their technical subject are working on. You don't need to know the nitty-gritty of that, but you just need to be aware of the fact that there is no answer key. They are judging the correctness of their own work, and they are creating original work. So, what are the conclusions of all this for you, for someone who might have watched the end of this video, someone who statistically probably hasn't been involved with these kind of Olympiads or anything like that? What are the conclusions for you? Well, I think the conclusions are that, and this is probably lifting somewhat from a 25-page PDF document called Lockhart's Lament, which is something that I regrettably did not mention earlier in this video, but I'm just realizing I should definitely mention this because this is what a lot of the ideas I had was based on. Going through the I'm going to include a link to the description and cite it as like something I referenced. Going through the creative frustration of trying to build chains of logic like the answers to these mathematical Olympiad questions, well, and being extremely conservative about when you go to looking at someone else's answer, which should be your last resort, only after several days of thinking. Often this creative frustration of trying to come up with an answer yourself is the most valuable experience you can have when you're studying for these subjects like maths, physics, comp sci, especially the creative parts of each. So the problem-solving parts of each as well. So don't go to the mark scheme for several days. It can take that long for your head to work through a problem. When I was practicing for these Maths Olympiads, there were some times that I would spend 6 days, 4 days, 6 days, periods of time around that long, looking at a single question. I'm leaving it on the whiteboard, going about my day, coming back every so often to think about it before I actually solved it. And solving it is just the most amazing, beautiful feeling once you have spent so much time on it. And the important thing is I actually learned a lot from doing that. And finally, most importantly, don't feel bad for feeling frustrated or feeling like you're stupid while you're doing math or other problem solving in science, because that really should be a signal that the kind of practice you're doing for your subject and like improving yourself in that subject, it means the practice you're doing is valuable. And people who know me in real life might think of me as someone who is pretty smart and therefore feels smart while they're doing math a lot of the time. And sometimes that is true, but that's mostly when like I've just solved something, right? But most of the time I can feel like I'm pretty stupid while doing maths or science, but I understand that that feeling is because I'm challenging myself, or that feeling is because I'm having to think really, really hard about what I'm doing, which implies that the practice I'm doing is valuable. So do not feel bad if that's how you feel while you're practicing maths or physics or comp sci or anything like that, any creative problem solving subject, because it means you're probably doing the right thing. So if you stuck around to the end of this video, I do apologize for the rambliness of this talk, but if it was something that interested you, be sure to subscribe for maths and physics content, and leave a comment if you have any thoughts on this, or email me at watchmedomath@gmail.com. So until next time, thank you for watching.